So exponential growth and decay, we talked about this quite a bit ago. You will definitely want a calculator for this. If you're using your phone calculator, turn it sideways so that you have the option to do exponents on it. You're going to need that as we go through this. So exponential growth and decay is how something grows or decays when it goes in a slope like this. So it can look like that or like this. This is a growth, and this is a decay. You can see it's growing or it's decreasing. I'm going to show you just some examples similar to what you'll see on the homework. Actually, most of them will be from the homework. So the first few problems you'll see are like this, or maybe they'll be the same equation but written like this, and you'll be asked 3 different questions. So let's just talk quickly about the difference between this equation versus this equation. All I did here was I took 1 plus 0.36 and combined it into 1.36. You can go backwards and change it back into this. Keep that in mind. The formula itself is a times 1 plus or minus r to the t power. So if you're given just some number in the parentheses and you know it's a growth, just do 1 minus the number you're given. Or the number you're given minus 1. Basically just cut the 1 off and it'll tell you what that growth is. Okay, so now that that explanation is out, let's answer some actual questions. What I want to know is, what is the amount we will have for whatever this situation is after time of 5 units? It might be 5 years, 5 minutes, whatever. All that means is we need to plug 5 in for t right here. So we're going to take our calculator and plug it in. Uh-oh, I lost my video, or my slides. Let's try this again. Okay, it is 5 times, so parentheses 1 plus 0.36, darn it, 0.36 to the, so remember to do the power, you use this caret button if you're using your calculator similar to this, 5th power. And we get 23.26. So if this is dollars, we'll say $23.26 or put whatever unit it is on it. Okay, the initial amount is this. So that tells us it's 5. I probably should have chosen a different number of years because 5 is the same for t and a. Whoops, sorry you guys. Just know they're 2 separate things. It could just as easily have been that 5 was 4 instead of 5. That changes based off the years. So the initial amount is just whatever this number is. The rate of growth as a percent is this number. So it's either the number after the decimal on the 1 or it's the number after the plus sign. And it needs to be as a percent. So we've got 0.36. Change that to a percent, we get 36% because you move the decimal to the right too. So you'll have a few questions like that. Then these 2 questions are exactly from the homework. I don't remember what problems they are. I want to say 8 and 9, but I don't know if that's accurate. You can look and find them. So write a function in terms of t that represents the situation. What we just saw on our previous slide was the formula is a, the initial amount, times 1 plus or minus, plus if it's growth, minus if it's decay or decreasing, the rate as a decimal, to the t power, and t is time, usually measured in years. So we have this population of 210,000. That is our initial amount, and it increases, so that tells us it's going to be 1 plus some amount, by 12.5%. That is R, but it has to be a decimal, so you move the decimal twice, 0.125. And then we just plug it in. 21 or 210,000 times 1 plus 0.125 to the t power. T gets to stay t because it doesn't tell us how many years have passed. I can simplify this down, so it's 21,000 or 210,000, sorry, I keep saying that wrong, times 1.25, 1.125 to the t power. Okay, if it's increase, as this word right here says, it's a plus. But you also have the option where it's a decrease. If it's a decrease, it's going to be 1 minus. So our next problem says write a function in terms of t, where the initial amount is $900 for a sound system, and that amount that it's worth decreases, so we'll do 1 minus. It's decreasing by 9%. As a decimal, we move the decimal twice, 0.09 each year. So we have our initial amount times 1 minus our rate to the t power. This simplifies to 0.91. It's 900 times 0.91 to the t power. Okay? You should begin to work on that homework now.